So picking up on number 2, I notice I have a common difference of 2 and a starting value of 6. So that'll really be information to be useful later. How many toothpicks will be needed for the 5th design? Explain or show how you found your answer. Well, if you notice here at design 3, we do have 10 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're adding 2 every time. So we add 2 to get to the 4th design, and then add 2 again to get up to the 5th design. So really, if you want to write out, you could do 2 plus 6 plus, 6 plus 2 plus 2 plus 2. This is the 1st design, this is the 2nd design, 3rd design, 4th design, and then 5th design. And that gives you a grand total of 14. And here where it says explain or show how you found your answer, where it says that I would probably put a little bit more like words here explaining what was going on. I'm just trying to go through, trying to have you guys have you hear the answer, and I'll let you do the writing. Moving on down here, B, write an equation for the total number of toothpicks T needed for any given design number N. Okay, well, if we just follow the form we have been using for sequences, you gotta do 2 in front of n minus 1, and then you add 6 on the end because that's your initial value. And so if you were to plug in any design number n here, like you plug in 1, you'd get 6 out. And this is just matching up with the functions we have been using. C, use the equation you wrote to find the number of toothpicks needed for the 14th design. Show your work. Alright, well, we'll do that. We'll just take 14, put it in for n. So you gotta do 14 minus 1 plus 6. 14 minus 1 is 13. So 2 times 13 plus 6. 2 times 13 is 26. Add the 6 there, and you got 32. So you're going to get 32 toothpicks. Moving on to 3, which is all sorts of fun. It's got exponentials, it's got linears, it's got all sorts of fun things. Alright, so read through the story problem, make sure you understand what's going on with both of the situations. Bank A is you're timesing by 1.025 in your account every year, and then bank B is just adding $25, and you start with 1,000. So write a function to multiply the amount of money with bank A. Remember, 1,000 is our starting value, and we have a common ratio here of 1.025. And so when you write your function, it'd be 1,000 up front times your common ratio to the n minus 1 power. And yeah, we're going to write it like that. And then we need to next write a function to multiply the amount of money to have with bank B. And with bank B, we have a common difference of 25. And so it's going to be an arithmetic sequence or a linear sequence here, linear function. We're going to get 25 times n minus 1. Add 1,000 because 1,000 is our start value. So there you go, functions for A and B. If you plan to leave your money in the account for 10 years, which bank would you choose to save your money with? Justify your answer mathematically. So basically this justify your answer mathematically, plug 10 into both, show how much you're going to have after 10 years with both, and then decide which one's going to be better. So let's do the first one. Let's do bank A over here. Take your function to figure out how much it's going to be after 10 years. Remember, you're going to have to make a little bit of adjustment when you plug in a number here, because you start counting the first number in the sequence is year 0, and so you're going to have to plug in 11 because the 11th term of the sequence is the 10th year. And so I'm going to plug in 11. You gotta do 1.025 to the 11 minus 1 power. 11 minus 1 is 10. Okay, and so when you calculate that, you put in your calculator, do 1.025 first to the 10th power. And then you have to times that by 1,000. And that gives you $1,280 and about 8 cents. So that's some pretty good money. 10 years gives you $280. Actually, that's not very good at all. As far as comparison to investments and stuff. Bank B, you gotta take 11 and plug it in, because it'd be the 11th term of the sequence. And you gotta do 25 times 11 minus 1 plus 1,000. 11 minus 1 is 10 again. You gotta do 25 times 10 and add that to 1,000. 25 times 10 is 250. And then add that to the 1,000. And so once you do that, Plan B gives you a grand total of $1,250. And so noticing 1,280 versus 1,250, Plan A is better. And so put that down, and you're ready to go. And that's it for the constructor response part.